In the previous video, we have discussed some of the key points related to STM32 nucleo board which have STM32L073 RZ microcontroller unit. So today let's discuss the operational modes of the microcontroller which is ARM Cortex-M0 Plus. So our microcontroller has two primary operational modes. First one is thread mode and other one is handler mode. Let's discuss about the thread mode. It is also called user mode. This is the default mode of operation where the application code runs. In the thread mode, our microcontroller can run in privileged or unprivileged state. In the privileged state, the code has full access to the all processor resources and system registers. In the unprivileged state, access to certain critical system registers and resources is restricted, enhancing the system security and stability. The use case of the thread mode, it is used for running the main application code, tasks and routines. The next operational mode is handler mode. This mode is entered when an exception or interrupt occurs. It is used to handle exceptions such as interrupts, system calls or faults. In this operational mode, CPU always operates in privileged state, allowing full access to all system resources and registers. This mode is used for executing exception handlers, interrupt service routines, and other critical system tasks. In summary, our CPU has two operational modes, thread mode and handler mode. By default, it is operating in thread mode. It moves thread mode to handler mode automatically when an exception or interrupt occurs, and it's returned to thread mode after the exception or interrupt is handled. So let's understand what we learned before with the help of a code demonstration. So you don't need to understand the 100% of this code. Just understand some basic principle which I am going to explain now. In the main function, we are going to print something before the interrupt occurs. Previously I mentioned normally the CPU operates in thread mode. So this statement should be print in thread mode. So after I generate the interrupt, the processor should be moved to handler mode. So when the processor moved to handler mode, it should be handle the interrupt. So here I am going to generate the interrupt pendsv. So the CPU should be moved to pendsv handler to handle the interrupt. So after the interrupt occurs, the CPU moves to handle this part of the code. After executing this part of the code, that means after printing this statement, that means after the interrupt handled, the CPU should be moved back to the thread mode. That means after handle the interrupt, the processor should be go back to the thread mode and do the rest part of the code. That means print this statement and execute the rest part of the code. Now I am going to debug the code and explain the behind scenes of the execution. So you can see currently the instruction pointer is here. So the program is currently going to execute this part of the code. And also you can see here, this is the general purpose registers in the processor core. You can see here I am monitoring the XPSR register value. You can see currently its value is this one. Let's keep monitoring this value while executing our code. So here I am going to press this step over button to run this part of the code. Just do that. So I have executed this part of the code, and now instruction pointer is going to execute this part. The value in the XPSR register haven't changed. Let's run this part of the code. So you can see I have run this part of the code, and you can see the console print that statement. Now the instruction pointer is here, and now I'm going to generate the interrupt running the code. Let's do that. Now you can see this value has changed. That means now the processor is in handler mode. So now the processor is going to run this part of the code. That means the processor going to handle the interrupt. So let's move forward. So you can see the processor has executed the pendsp handler. That means the processor has executed this part of the code. Previously I mentioned after handle the interrupt, the processor should move back to the thread mode. So let's move forward. So you can see the processor has moved back to the thread mode. You can see the processor value, the register value has changed. That means now the processor has in thread mode and it is going to execute this part of the code. Let's move on. Now you can see processor has print this statement. That means the processor has executed this part of the code and now the processor continuously executing other codes. So thank you very much for watching this video. I hope you have understand the concept, and if you have any question, please put that in the comment section and see you in the next video. Thank you very much.